All right, so limits at infinity, example number 2. And to be honest, I'm not sure if I have any on the homework that are like this, but it's quick. Let's cover it anyway. So, the idea is that when you apply a limit as x approaches infinity to a fraction, and this will come up later on, I believe it'll be assignment number 40, our very last one. But I want to remind you that the limits at as x approaches infinity, basically it's the same logic as finding horizontal asymptotes. So the behavior of a graph as x approaches infinity, as x gets very large, we talked on example 1 about the fact that the largest power of x is going to have the most impact the bigger the x gets. So when we find the largest power of x in the entire fraction here, in the entire fraction, and notice that x squared would be the biggest power, and these are the two terms that have x squared in them. And all we have to do to find that limit is use those coefficients. So this first one, that would be a coefficient of 5, and that'd be a coefficient of 2. Boom, all right? So, there's a lot of theory there. I know I kind of went through it quickly, but let's not overthink it. So there you are. And that would be the horizontal asymptote of that graph if we were going to graph that function, is y equals 5 over 2, 5 halves. The limit as x approaches infinity of 2x minus 8, you see it, all right, 3x squared and so on. So here's the deal on this. This is a little tricky. The largest power of x in the entire fraction, okay, is x squared, in the whole fraction, isn't it? So here's the x squared term here, and you go, where's the x squared upstairs? There really isn't one, but there is. The point is, you don't find the highest power up here and compare it to the highest power down here. It's in the entire fraction, x squared. So the coefficient on the bottom is easy, that's 3. But on the top, what is it? What's the x squared on the top? What's the ghosty thing here that you maybe can't see? 0x squared. That's what I'm trying to draw there. Ghosty 0x squared. The coefficient of x squared upstairs is 0. And 0 divided by 3 is 0. See, the bigger the x gets, that x squared is going to grow at a faster rate than the x. And so the whole thing's going to go towards 0. Anyway, they're pretty easy.
That was easy.
All right. And then finally, well, yeah, I might end it on this one. Let's see. The limit as x approaches infinity. I think once we get done with this one, that'll suffice. Okay, so what's the largest power of x in that entire fraction? In the entire fraction. Anyone? Cubed! Yes. Who said that? You. Okay, thank you. That's right, third power. So here's third power. And so upstairs the coefficient is 6. Then you go, well, where's the third power on the bottom? There isn't one. Well, isn't there a 0x cubed? All right, I didn't make it ghosty so you could see it better. So that coefficient would be 0. And so that limit would be 6 divided by 0. What? Did you just say divided by 0? You can't do that. That didn't work. So I would hope you would look at that and you would say, well, what do we call that when we have something like 6 divided by 0? Undefined. Now, in the language of limits, what's that mean? The limit does not exist. There you go. So there would be that one. And I don't know what else to say there. There's 2 more, but I think that's enough. I think we can get on with our lives. So, again, sorry, I gotta do something here. I don't know, it's blitzing out on me. My computer is freaking out. I don't know what to do here. I guess we'll just pause it. I had a nice, awesome, really hilarious cartoon for you to look at here about x approaching infinity, but apparently it doesn't want to work, so let me try it here. Okay, you're like, no, we don't care. We already hit stop. Okay, that's cool. But, okay. This, after all that build-up, you're probably like, this probably ought to be really good. But anyway, as x approaches infinity, don't let him go off on a tangent. He goes on forever. That was worth the wait, wasn't it?